Hello, this is the lecture number 10 of the chapter Continuity and Differentiability, and in the last lecture we were discussing the exercise 5.5. Let us take some more question of this exercise to have a good command over these types of questions. Let us take another question, that is the question number 8, and where you have to differentiate sine raised to power x plus sine inverse root x. Now again, as we have discussed in the last lecture, whenever we have the plus or minus sign between the functions and individual function cannot be differentiated without taking the logs, then we have to let them individually and find their derivative individually and put it here. So we have let that sine x raised to power x is equal to u and sine inverse root x is equal to v. So d by dx will be equal to du upon dx and dv upon dx. And we have let here u is equal to sine raised to power x and v is equal to sine inverse root x. Now this function cannot be differentiated without taking the log, but this function can be differentiated without taking the log. So we can differentiate it directly without taking the log, but this here we have to take the log. So log u is equal to x log sine x. By using the properties of the log, the power get multiplied with the expression log sine x. Now differentiated 1 upon u du upon dx. Now product rule will be here, use will be here. So I have differentiated x will be equal to 1 plus x multiplied by the derivative of sine x, log sine x. So log sine x ka derivative 1 upon sine x into cos x. First of all differentiated log, which is equal to 1 upon sine x, and derivative of sine x is cos x. So cos upon sine, it comes out to be cot x log sine x and multiplied with u, and the value of u is sine x raised to power x. So this is dv upon dx. Now sine inverse root x can be differentiated without taking the log. First of all differentiate sine inverse, then multiplied with the derivative of root x. So derivative of sine inverse is 1 upon under root 1 minus root x square, because in place of x we have root x. Multiply with the derivative of root x, which is equal to 1 upon 2 root x. You know the derivative of root x, which is equal to 1 upon 2 root x. So it becomes 1 upon under root 1 minus x and multiplied with this. So this is dv upon dx, this is du upon dx, and replace these value in the expression number 1, where dy dx is equal to du upon dx and dv upon dx, and it is derivative of, we have done that log u is equal to 1 upon u du upon dx, because we have differentiated u with respect to x. We have put dv upon dx because we have differentiated v with respect to x. So we have done at least 2 questions by taking the logs, and there are many questions in this exercise, and you do all this to have a good command over these types of questions. Now I'm taking one more, that is the question number 6 also. Again, this cannot be differentiated without taking the log, this cannot be differentiated without taking the log. So I've let it, this is equal to u, this is equal to v, and this is equal to y. So dy dx will be equal to du upon dx and dv upon dx. Now we'll differentiate them individually, that is u and v. Now u is x plus 1 upon raised to power x, and v is x raised to power 1 plus 1 upon x. So taking log individually, see it very carefully. Log u will be equal to x log of this. Log v will be this log of this. Power get multiplied with the log. This multiplied by log of this, log v will be this multiplied by log x. Property of the log we have used. Now differentiate very carefully because we have many terms are there. So log u is equal to 1 upon u du upon dx. We have to use the product rule. So first of all I am differentiating this log x plus 1 upon x. Now what is the log derivative of this? First of all differentiate log. So log ka derivative is 1 upon this here. Multiply by the derivative of this. Now the derivative of this is 1, and 1 upon x derivative is minus 1 upon x square. So this is the, we are using the product rule. This multiply by the derivative of this, and the derivative of this we have discussed. First of all derivative of this log multiply by the derivative of this, plus derivative of this multiply by this. So derivative of x is 1. So it is only log x plus 1 upon x. So du upon dx will be u multiply by this expression. This have simplified it, x square minus 1 upon x square plus 1 upon x square. To have simplified it, so multiplied with u and put the value of u here, whatever is the value of u. It is x plus 1 upon x raised to power x. Similarly, the v portion, log v will be equal to 1 plus 1 upon x log x. Differentiate both sides. Log v will be, derivative will be 1 upon v dv upon dx. Because we have differentiated v with respect to x, use the product rule. First of all, I have differentiated this log, which is equal to 1 upon x, plus derivative of this will be equal to 0 minus 1 upon x square. Derivative of 1 upon x is minus 1 upon x square into log x. And dv upon dx will be equal to v multiplied by this expression. This expression is this. The value of v is this. So this is du upon dx. This is dv upon ds. Dv upon dx. Put these values in d by dx. d by dx will be equal to du upon dx. dv upon dx. So you take your own time, take your own space. You do individually on the individual page so that you will not get confusion, and put the value of this du upon dx and dv upon dx in this expression. So you take your own space and time to differentiate this. These are very good questions and important questions also. Similarly, in question number 7, y is equal to log x raised to power x plus x raised to power log x. Because we cannot differentiate them without taking the log, so you have to let them u or v as we have done earlier. So y will be equal to u plus v, and dy dx will be equal to du upon dx plus dv upon dx, where we have let v is equal to log x raised to power x and u is equal to x raised to power log x. Now we differentiate this by taking the log. So log v will be equal to x multiplied with log x. Power get multiplied with log x. And x log x, taking log v will be equal to log x multiplied with log x. Power get multiplied by the log of this. Now differentiated, log v ka derivative will be 1 upon v dv upon dx. Now we have to use the product rule here. I have differentiated x first, multiply with the second function, plus first function multiply with the derivative of this, or this derivative you have already done 2 to 3 times previously. So first of all differentiate log, that is 1 upon log x, and derivative of log x is equal to 1 upon x. This x will be cancelled out. So this comes out to be 1 upon log x. This is log x multiplied with b, and the value of v is log x raised to power x. So this is dv upon dx. Now this is u. So du upon dx, taking log, so log u will be equal to log x log x. This multiplied by log x, and 1 upon u du upon dx will be, first of all derivative of this I have taken 1 upon x, and then 1 upon x. These both are same, so you can write twice log x upon x multiplied with u, and the value of u is x raised to power log x. So this is dv upon dx, this is du upon dx. You can put this in step number 1, and the step number 1 is this. So du upon dx and dv upon dx you can replace here, you will get the value of d by dx. Similarly is the question number 9. Again you cannot differentiate them without taking the log, so you let u and v, d by dx will be equal to du upon dx and dv upon dx. Now u you have let x sin x, v you have let sin x raised to power cos x. Taking log on both sides, differentiate and obtain du upon dx. Differentiate again, you can obtain dv upon dx. And we have these type of question we have explained or discussed earlier. Put the value of du upon dx and dv upon dx in this expression to get the d by dx of this expression by taking individually. So these are the questions we have done by taking the logs of individual terms and differentiating them individually by taking the logs and putting the value of du upon dx and dv upon dx in the original function to get the derivative of derivative of y, which is equal to d by dx, du upon dx, dv upon dx. So we have discussed many questions by taking the logs. You should have a good command over these types of questions, and we'll discuss the remaining questions in the next lecture. Thank you.